I'll introduce you to the section of my bias. Let's go ahead and let it roll. Alright, so I'm going to hit the key button and bring it in 1 second at a time. Let's let it play first and then I'll bring it in. I'll back it up. So you know how far we're going in the video. Just a few seconds. That's how far we're going. Right about, we're going to jump in a second. It's the mayor, I think, on the walk. And their assistant photographing. See the punctures, number 28, number 23. You see the cars under there where the pool is. You see the lack of reinforcement here. I guess I will talk up real quickly. Lack of reinforcement here. I think by the time the fire department gets there, they put a lot of reinforcement in, a lot more poles in. You see this was sheared off, that no reinforcement here. Numbers clearly in plain view, not even a scrape, so that was a clear breakaway. I'm going to go back in a minute. We see the wall here, a little bit of a ripping away from that. That's probably that other wall, the garden wall that was tied to it. Probably ripped away a bit or arched away. Once you take note of the foot job here, right here is where it started coming out here a little bit. Yes, you can barely see the reinforcement right there. Right where my mouse is. See that little bit of reinforcement? That could be because of this going across from here over to there. See this, the line? Or not. I'm not sure. It's reinforcement, but I just don't know. It's duty. Oh, and the spacing is awesome there. So whoever did that, the spacing is like, you know, it's very consistent. Spacing is very consistent here. It looks about 6 inches, I would guesstimate. Go back up. All right. You know what? We'll back up now. We'll do this. I want you to take note that I believe that's the 1'6" elevation change. It's up into the lobby area. I want you to note the cones, the deck that behind it, the planter, where there's no reinforcement. Looks like a lot of layers. No reinforcement sticking out. Maybe at the bottom it might have been some. I want you to notice these two pieces of bar here. We've already looked at that in another video. Over to your left here, we see a very high placed piece of reinforcement, and there appears none here unless it was ripped out and we don't see it. That's column 7-1. We can see that no rubbing or removal of the material happened there. We see that so it didn't lean that direction. There's the shear plane, I believe, created, just clearly just dropped down. I think I'll address a new video that people are trying to circulate already. I've already went over that myself. Yes, I saw the crack at the top of the structure. I looked for the repairs in the, I don't know, 300-page report. In 2002, that stuff was worked on. That crack is also in the overhang, not in the structure itself. The others are clearly, apparently, just mapping of the blockwork from inside and stucco, etc. So there's nothing to get excited about there. You don't see any full cracks. And so, no, bite me on that one. Here's the thickness of the pad. There is a wear layer added, as you saw right there. That was a layer added, and it's not for free to add those layers. We'll go back in the video. We'll let them play around here. So right there, there's some, mapping of the structure where you would see it, but there's a full crack. There's the mapping of the structure where it took a torque. Remember, in the other end of the structure where it took a torque and you get this buckle. So that'd be a rotation. As we look at it, it would be counterclockwise, pulling of it that direct. So from left to right, you can see it taper off. So your software that you want to think of, you actually can see it here. You don't need software to see it. You can literally see it change, smaller, larger. larger yet. And then a different reaction here compared to, you know, software might have put it down to here at the floor level, saying to get to there, you have to do it at the floor. Apparently, you don't have to do it at the floor to get that torque up there. That was probably a higher torque. Some of this was already damaged. I don't see the inspection hole anymore. Thought it was an inspection hole here in the report. We see the deck, but what we're looking at here is a lamination, the paver or the stamped concrete maybe, and then the real deck is down here. I'm going to back this up, of course. I'm looking at the edge wall here. So this is, I will strongly say this is just settlement out here in the soil around you, because the pool is right about here, and the pool is status quo. It's got water in it and everything, and this looks like it might have been just settlement of the decking area. Either that, or they somehow ran a straight line, put it on the stucco, and then let that stay exposed. It's kind of weird though, because you see the profile of this. I don't know whether it's stone or not. Obviously, you don't make a profile like that. I don't see it up here either. So this is an odd duck, but it's still in my brain to be considering for consideration. The wall doesn't show any cracks down here, minus this right here. So it does show that they capped it at one point. This might be block, and then they capped it, and this is what you get with your cap, your quality of construction. And an open state, non-union state. Yes, that was offense to the to that. Okay, so then we go right here. Let's back that up. Okay, I think it's going to happen out of nowhere, so I got to stay right with it. Let's go back. Shit. I'll show you what I saw in a second. So what I see is that, yes, there you have this stucco mix that's kind of shitty. We're way on the side end of the structure where there's no issues. Okay, now we'll do frame. We're stepping over the wall, looking into the part I believe was initiating, and we're going to look for reinforcement. And what we find is that 3 bars on this side, 2 on that side, 1 there high. This is middle. We see that the reinforcement, as this punctured down, it just slipped all the way down to there before releasing. Right about even with the deck there, that reinforcement. So before it let go, and it seems like it aligns with the car below it by chance. I'm gonna have a little fun in a second with one of my comments. So let's see how. So you got to be careful with me sometimes. The firebox, fire extinguisher is still in place, so nothing even came through and knocked that off. So the puncture happened, it fell. A little bit of lateral movement after it fell to the ground from that deck over there doing the torque. I think pushed this over just a little bit to the left. I based that on this leaning up now. This piece leaning up, so I based it that the deck fell. It had a torque to the left this direction based on that. This car was up here. That's where up here at one time is the separation, and here's will be my fun section in a second. This is a ladder form foundations. You put your block wall on top of a ladder system, and yeah, you see the holes, so the concrete fell through it, and now it's on top. You can expose the ladder foundation. All right, so I did that straight face, right? I can't help it. I do some stuff. Now, that's literally a ladder. It fell down somewhere. It was up here. I don't know where the ladder was, but it fell over. It's literally a ladder, and I couldn't resist myself. Sorry, guys. That's got nothing to do. That's just a ladder, literally a ladder. It's got nothing to do with the foundation. But yes, I tell my jokes straight like that. You should see sometimes I'll say just for reactions to other engineers and contractors. But the worst part about it is I say it so straight that you believe me. All right, there's the planter box. We talked about that in the previous video, that cutout, the planter box. I believe we find that in the flyover. The planter box is here. And there's literally, oh great, there's literally the ladder. And what happens is that lens, again, compression pulls it over and gives you a false illusion of what you're looking at. There's the wall. We're looking over the wall. We're looking at there to the left. That's that supporting system. Generators out here already. So this is morning. So I guess they fired up the lights. Uh-oh. So when it went down, I think it took a little, I think when this went down, it pushed a little to the left and we get some torque going on. And so some of that's that. Let's go here. So that ladder, you know that now, now you know it's literally a ladder, and this is part of it. When the deck failed, this is where, so this is where your plane started. You see this is still intact? So it was undermined right here. This is not, I'm not playing anymore. So there's your rebar tying in this wall system, but right there was where, and it shows up right there, is where our start of our shear plane started. Leaving this intact to your right, to our left. So that 1'6" elevation, I think someone else wrote me in emails trying to figure it out, showing the beam underneath. Well, here, I have it up here, that this would be the elevation. That's from the lobby where you'd walk down from the elevators and look out and look at a collapse here, or one behind here. I think there's a glass also. All right. So, talking about visitor parking. People talked about visitor parking and they're overloading the location. That they should have had lighter cars up here, if anything at all. Hindsight is 2020, and yeah, this should have been a no park zone over there. Put it all over here. Lighten the loads. Take a load off, Annie. Anyway, so I'm gonna go frame by frame on this, and tell you what I observed. What don't we observe? Broken glass. So if you were looking at the structure real fast and trying to evaluate whether it's safe to go inside, I can tell you right now that glass isn't fractured. Now you would go up to that glass and tap on the glass. If it's real taut, it's got some pressure on it. If it's got the regular deflection of normal glass would, if that size and shape, you would know it. It kind of takes the wind pressure, kind of like a wobble. So quickly you could evaluate that. So I know there's some engineers that are watching this. It's supposed to be first responders. That I do not find that inside their manual of first responders. I've been reading their book. Hell if I know it is. Their book on their first responders. That's so you know where your penis is. I didn't know. I had to look at it. Oh well, we're holding out on that one for you guys. Pile penetration. Somebody's like, oh, you can drive piles. No problem at all. You don't know what you're talking about. I said they fracture. And this whole article's about piles, and you see the piles of fractured piles. Piles love fracturing when you try to drive piles. These are poured in place, not driven piles. So those are the heads of them. So bite me. Bite me the doors. Bite me 2 times, baby. Whatever, right? So anyway. So back to this one. So we have a puncture. Let's go back to the video, which is hiding out 2 over right here. So I guess the manual's lost in translation over here. So there it is. U.S. Army Corps of Engineers Urban Search and Rescue Program. In here, they do not. I could not find the glass as a form of checking the. You're talking about wind coming to it, but you see glass. That's it. Not how glass can be used as an indicator of what's going on with your structure. That you could quickly evaluate, saying square, glass is square, awesome. This is quick, fast shit you can take on. Okay, car stable, pushed against this one. I can step here real quickly. Is this column going to buckle? Let me take a look. So I can climb down. Well, if I can get to this truck, then it'd be better to climb down. I already can evaluate real fast as the ground, so I'm only going to fall a little bit more. If I wanted to get in there real fast, I can get in there real fast. Speed is of the essence. Everybody will tell you, take your time, take your time. No, speed's of the essence. You want to get the data real quick and get the hell out and process your data real fast. Number one, this glass. You'd also want a spotter. Somebody tells you glass just cracked, and next word, it's your ass. Of course, being next to a column would normally be a safe place, but next to this column, it's a draw, right? You get four sides. On this side of the column, you're dead. On this side of the column, you're safe. So, where do you go? It's just a draw. If you knew how a building would collapse, then you would know where to go. In this case, being close to the wall over here might have been a safe spot. Being in a car definitely seems like a safe spot at this point. I went too fast. It was 10 seconds. So then we rotate. We look at, again, the rebar here is one bar in there. So we get a point of failure pretty evident, I think, of the deck these cars are loading on. So there's my smoking gun for this deck failure over here. Tom, you asked me about the car. Smoking gun here would be right here, that this deck was the reinforcement going that way, and the cars coming here all the time. So I'm going to talk about snowplow effect. All of them coming down this driveway, stopping, turning, looking for a spot. When you stop, you surge your car. In front of your car comes to a stop, you surge it, and they need speed bumps basically. So you surge it, and very slow down the speed bumps, not a high impact speed bump because that would have the wrong effect also. So you're surging it. This cycling that I talked about of rebar flexing obviously had so many cycles that at this point it broke free. These cars were out here with the weight of that deck broken free underneath of there from here, and the weight of these cars allowed it to just drop and shear off all uniformly, this entire load out here, only being connected to the structure at the main structure by the window by nothing, pretty much, and one piece of steel here, and then the rest right in the cycle zone, where the concrete keeps getting cycled with the cars driving over it, flexing. You only have your two pieces of rebar here, and who knows how long that this deck on this side was holding up that side. And obviously through, I call it accelerated creep, because we don't know the timeline, but my point being, and I know people don't like my accelerated creep comment, engineers don't. My point is that those stresses were there just waiting for the right load to be applied, and then it just needed that little tap to push it over. So it's not acute. This was over time, the cycles that took many years to do this, covered up with maybe a laminate right here, and other structural defects such as the lack of rebar. I won't say structural defects, I don't want to be in court, such as the placement of rebar with the one piece there. No one in their right mind is going to say that is punk shear protection. No one's going to call this punk shear protection, not even 1976. Well, obviously they did in the township. I take it back. This column went away from us. It punctured and went away. So when this deck collapsed, part of that deck was on here. It punctured, but the deck itself slid down here, so we should see numbers removed. Bent this over and pushed it away. It's at a plumb. The rest are pretty much in plumb, so that's your direction also. And a slight bit of rotation. This is where the one viewer said he fixed the gate. 1998. A couple years before they brought in the guy to do all the major work. Here's a fracture, a single fracture between the columns there, going across here, lining up probably with this column here. Okay, so there's your three pieces of rebar, maybe four. So too high, maybe there's two more. Too high and center line on these guys. Maybe there's 6 pieces there, but that's pretty nice. I mean, not nice, but better. So that looks like a piece, if I'm getting it right. Looks like it's 4 pieces there, maybe even this side came from that side. 5. But you don't see the numbers rubbed off. So the puncture on this one, okay. So it is on this one, it appears it broke free. It did rub against the wall here just a bit before it came away. On this one is a clear breakaway. Let me think about my bias. So I get my butterfly effect. Here's my bias. I'm confirmation bias now, so that means I'm trying to prove my theory. It's in a video tomorrow. Confirmation bias. That means I'm accidentally, on purpose, subconsciously, unconsciously, consciously looking to confirm my butterfly, not letting go of it. And with that said, come on, really? With that said, if the butterfly happened in the middle, be careful of my bias. But the butterfly happening in the middle would pull away from this side, and on the back side of here would get this scraping right here, temporary scraping before it breaks free. So again, confirmation bias. So you need to be able to verify that. I mean, a video would be beautiful, and I don't have a problem, putting all this work in. The video shows it started out in the deck and worked its way over, and like good. And that's just more data that I'll know next time that whatever. But I don't think this is clear. This just broke free. No letters are rubbing. This rebar is rusted. So previous video I said the rebar looks good. This rebar does indicate rust jacking. So the other video I said I couldn't find any bad rebar. This video I'm finding rusted rebar reinforcement. Not fractured all the way, but this means it expands. When it expands, and there's your right there's your stirrups. So when it expands, it loses grip force. In this case, it also has concrete on it though, so that would be part of cycling. But no cars are over here, so this is just the deck weight. I'm not discounting it at all. I'm saying it does matter. It just makes it easy to punch away, punch away from this. The lack of engagement, a little bit of paste on this. Now the other ones just really show lack of engagement because you see clean rebar. This rusted rebar has paste on it at least. The others do not. Sprinkler system still in place. It broke somewhere else then. We're at the deck. There's one of your planter boxes. It seems to be aligned with column 31. So everybody from 29 over, you can now see why that you still have stability, stable there. And let me get back over that wall. That's the one I want to see. This one. This is the one that's on the angle. I've said in the previous video one back. A little bit of, there's the head of it all ripped off. This is punk shear. Looks like a dome left, and that's probably where the top of the concrete was. So punk shear on that one. And again, that's my abbreviation, punk shear. Puncturing shear, you can go out that long word if you want. Anybody triggered by that, I apologize for triggering you. That's not my intent. All right, so again, there's bevel, the punk shear. And let's see if I can back it up. As you can see, this column has no abrasions on it. You can read the numbers clearly. So that's just a straight punch here. As you can see above this car, marked with nobody in it, TFL, tough fucking luck, X. Anyway, so you see no reinforcement sticking out this direction. You do see the full concrete though. The full concrete is present. Oh, forget that. Let's think about this. This is how you would tie the deck into the original structure over there, the one that the earthquake happened. So here's your deck tied into that structure. Let's call this the wall there. That pulling away creates the shaking effect, the vibration, and ultimately the ripple effect up the walls, causing the walls to, with the minimum spacing, this is close spacing, minimum spacing, minimum reinforcement, and all being concrete columns, as you know, slender columns all the way up, reduction in PSI, in fact. The interaction between the floor, you can see this where the shear plane was created. So what does this tell you looking at this is that when they poured this floor, obviously reinforcement was not, I don't know what's going on here, reinforcement was not going across here. Maybe I'm missing something, because it does look like a lot of lateral up and down type stuff, which means what? This is a beam. Those are stirrups I think we're looking at. And they tie the deck to the side of this beam, this elevation change. Maybe it goes up to here, and then this is a concrete knee wall, if you will, a block knee wall with stucco on it. So maybe there's a 1'6" elevation right about to there. Maybe the bottom of it there. Maybe 1'6" is right there. And then it's changed over to block and stucco. But this is that beam. What I believe we're looking at are stirrups, exposed stirrups, and a concrete deck ledgered to this, ripped off. And this would, on the other side of the building, this would get a ripple effect, or shaking and rattling and tearing the building apart. Over here to your left, we do not have the stirrup or connection. We just got the slab just continuing over. Come on, please. Continuing over into the driveway section of that. Let's see if she goes back, but he or she goes to the left of it. So you quickly look at all these windows. You see no breaking or buckling, so you don't get all excited about that. All right, let me go back to there. Again, so this is the driveway section of that. Looks like something serious going back there. I don't know what it is. But the again, so this is my valuation now with this presenting with you, and this will be a new statement about how this punctured down. Is that where that lady is back there? I don't know where that lady is. She's somewhere. They're in that garage looking for some lady. Maybe she's over there, way in the far end. I would guess, or against this wall here in parking garage area, where she's on the first floor, perhaps. So I would not put it over here. And this one, though, we have the dog action image. Oh, I just better pull that up. So right here, the cars. So right here would be where I'm talking about, where this is the deck, and this deck connection looks like that's an overlay. Looks like a clean line overlay. See it beautifully done. So that's your overlay, and that's the stamped concrete they're referring to. Okay, so we got our pavers out here and our overlay in here, I believe, and that overlay helped. That's the overlay that's left. That's weird. There's the overlay, a little bit of the overlay right here, smooth surface, and then part of the concrete where the overlay overlapped the decking is here, and it pulled down. So the seam is actually, for the concrete, the reinforcement, appears to not be over a column. Yeah, I see no reinforcement sticking out right there, besides this one piece. Ending the video. You guys can chase this and beat this up, but I need to sit on this for a minute because I don't see. If that's the overlay, I see the overlap happening not on top of a column, but further back. Not near a column, or I see it further back here. I don't see any cross steel. Okay, so I don't see the cross steel. And then we get this ripping down. All right, so I still have it here. I'm still here. Let's look for the numbers again. Numbers are clear. 48. So no rubbing took place there. There's a little bit of drop down there where that car is leaning against it. And ending this video. Take care. I hope you gathered something from this one. No, video's not stopping.